n players playing so-called speed bingo. In this game, each player has k numbers on their card, and the bingo master draws this number in some order which is picked uniformly at random. And when the number is drawn, each player, the first player that has this number can cross it out on their card, and if the number occurs in the card multiple times, the player can only cross it out one time. The problem asks for each player to compute the probability that this player will lose the game, which happens if this player is the last one to cross out all of their numbers. So to answer this problem, we need to consider for each number in the card of this player what is the probability that this specific number would be picked last. Without loss of generality, we can assume that within their own card, each player crosses out the same number in some specific order, for example, left to right, and then basically what we need to count is, assuming that the distribution of numbers is picked uniformly at random, the probability that some specific number is picked last is essentially the same as the probability that this specific number is picked first. So, and to account for the fact that players can only cross out this number if there's the first player at the moment who didn't cross out it earlier, we need to check for each number in the current player whether there are any occurrences of the same number in the cards of later players. So if there are such occurrences, then the probability that this number will be crossed out last by this specific player is 0, because even when this player crosses out all of occurrences of this number in his card, there will be still some other players that would be going to cross out later occurrences of this number. And the other situation is that this specific number only occurs either with this player or in the cards of the players that have lower numbers. And in this case, the probability that this specific number would be the last in the permutation is the total number of occurrences of this number in all cards of all players over the total number of numbers in all cards over all players, which is n times k. And after that, we just simply sum up these probabilities over all numbers in the card of this player, because them being last in the distribution as independent events.